Before we start solving 3 by 3 systems, let's open up with some practice on 2 by 2 systems and make sure we're good with that. So here I've got x all by itself. I think the easiest way to do this is going to be substitution. So I'm going to take this right here, and since that equals x, I'm going to plug it in right there for x. Okay, so I have 2 times 2y plus 7. Okay, so this is the substitution method, plus 2y equals 29. Okay, so I can distribute and I get 4y plus 14 plus 2y equals 29. On this next step, I'm going to combine these like terms and I'm going to subtract that 14. So I've got 6y, and then 29 minus 14 is 15. And then I'll divide by 6, so I get y equals, okay, and then this simplifies. 3 goes into both of these, 5 times and 2 times, so y is 5 halves. Okay, so there's my value of y, and then I can plug that into either of these two originals to get x. I think the top one's going to be the easier way to go. So I've got 2 times 5 halves plus 7 equals x. Okay, these 2's just cancel, so I've really just got 5 plus 7, which is 12. So there's my value of x. So the point of intersection of these lines is 12, 5 halves. Number 2, I think elimination is going to be the way to go. I think eliminating the y's will be the easiest way. If I just multiply this one here by negative 3, and I'll bring that right down here, I'll get negative 9x minus 3y equals negative 12, and my y's will eliminate. So 5x minus 9x is negative 4x, and negative 8 minus 12 is negative 20. Okay, and then I divide by negative 4, and I'm going to get x equals 5. Now I can substitute that into either of these. I think the top equation looks easier, so that's 3 times 5 plus y equals 4. That's 15 plus y equals 4, and I'll subtract that 15. And 4 minus 15 is negative 11. So I get 5, negative 11 as my point of intersection. Number 3, I think elimination is going to be the way to go here, and it looks like it's already set up for elimination. X and negative x cancel, so x's are gone. 7y plus 5y is 12y. 9 plus 15 is 24, and I'll divide by 12 and get y is 2. Okay, then I'll plug that into the top equation. So that's x plus 7 times 2 equals 9. So that's 14. Okay, so if I just subtract 14, I'll get x equals, and then 9 minus 14 is negative 5. So I have negative 5, 2 as my point of intersection. Then number 4, elimination is going to be the way to go. Neither of these x's or y's set up nicely for elimination, but if I multiply this by 3 and this by 2, I can make these y's eliminate. Okay, so I'll just rewrite that over here. So I've got 6x plus 6y equals negative 12. And then 18x minus 6y equals 60. And the y's have eliminated. 6 plus 18 is 24. So 24x, and then negative 12 plus 60 is 48. And I'll divide by 24 and get x is 2. Okay, I think the top equation is going to be the easier one here. So 2 times 2 plus 2y equals negative 4. Okay, so this is 4, so I'm just going to subtract 4 from both sides and get 2y equals negative 8. and divide by 2, and I'll get y is negative 4. So the intersection happens at 2, negative 4. Today we are going to solve 3 by 3 systems of equations. So that means 3 equations with 3 variables. So first we're going to solve by substitution. The first step is to solve for one variable. We want to get one variable by itself. The easiest place to do that here is solving for z by dividing both sides by 3, and I get z equals 2x. So I've gotten a variable by itself. Now what I want to do is substitute that result into a different equation, or possibly 2 equations. Z shows up here and here, so I'm going to plug that value of z in right there and right there. So I'll get 3x plus y minus 2 times, and the z becomes 2x, equals 1. And 8x minus 4y plus 2, and that z becomes 2x, equals 12. Okay? So what I have now is 2 equations with 2 variables. That's part 3. 2 equations, 2 variables. I want to simplify those, and then we will solve as we normally would a 2 by 2 system. So that right there, negative 2 times 2x is negative 4x. So I've got 3, now I'm going to combine that, so cancel that. 3x minus 4x is negative x plus y equals 1. And then here, 2x times 2 is 4x, so I've got 8x plus 4x, and that's 12x, minus 4y equals 12. So I've got 2 equations, 2 variables. So now I just continue to solve this like I would in any other 2 by 2 system. So I want to eliminate those y's. So I'm going to multiply this one by 4. And I'll rewrite it down here. Negative 4x plus 4y equals 4. So I've distributed all across that equation. 12 minus 4 is 8, so I've got 8x. Negative 4 and positive 4 cancel. 12 plus 4 is 16. So I divide both sides by 8, and I get x equals 2. Okay, so now I'm going to plug that in somewhere to help me find the value of something else. I think the easiest spot is right here. Z equals 2 times x, so z is 2 times 2. So z is 4. And I got that by plugging into this, which is just a modified version of this. So I'm going to say my x and z, they definitely check out here. So then I can use x and z to find y, and I think right here in the middle equation is going to be the easiest spot to do that. 3x plus y, and I should change that x to a 2. 3 times 2 plus y minus 2 times z, which is 4, equals 1. So that's 6 plus y minus 8 equals 1. 6 minus 8, that's like terms, y minus 2. And add that to y equals 3. Okay, so I got that answer by plugging x and y in here. So I'm certain that my x, y, and z are going to check out here. But I need to make sure they work in all the equations. So 8 times 2 is 16, minus 4 times 3 is 12, and plus 2 times 4, which is 8. 16 minus 12 is 4, plus 8 is 12. So they check out there. I know that's correct. What this really means is we've got 3 lines in 3 variables, which means they are in a space rather than a plane, so it's 3-dimensional. And the 3 lines all intersect at the point 2, 3, 4. X, Y, Z. Okay, number or letter B. Again, by substitution, I would say, let's get y by itself. We could get z by itself. We could get x by itself. I'm choosing y. So I'm going to move that x over. Y equals 8 minus x. I'm going to plug that in anytime I see a y, and that is just right there. 7 times 8 minus x plus z equals 36. Not sure why that happened. Let's go back. That's better. All right, now distribute. 56 minus 7x plus z equals 36. Move that 56 over by subtracting. Negative 7x plus z equals 36 minus 56 is negative 20. So I've got an equation with an x and a z. And over here I've got another equation with an x and a z. I'm going to bring this over here, and it's all set up to eliminate. I've got a positive z and a negative z. 5x minus z equals 14. The z's eliminate. Negative 7 plus 5 is 2. Negative 20 plus 14 is negative 6. That should be negative 2 and negative 6. Divide by negative 2, and I get x equals 3. I've got my first variable. It would be easiest to plug that into the top equation. 3 plus y equals 8. Subtract that 3, y equals 5. And I did that in that first equation, so I'm certain that first equation, my x and y will check out. And if I really need to check, I've got 3 plus 5, that does equal 8. Okay, now I can plug into either of the next two equations. How about the second one? 7y, 7 times 5, plus z equals 36. That's 35 plus z equals 36. And I subtract that 35 from 36, and z equals 1. I got that by plugging in there, so I know that's correct. Now I want to make sure it checks out in all three equations. So 5 times 3 is 15. Minus z is 1, does equal 14, it checks out, so I know my answers are correct. So that intersects, those three lines intersect at the point 3, 5, 1.